Okay, I want to start. I have to be done today by 1:45, and if I keep talking, would somebody raise their hand and say, you said you would be done by 1:45, and I've got to be at another thing at 2 o'clock, and I've got to be ready for that. So if you would, time me and keep me on the straight and narrow. I probably just be well done and we'll be well on our way at 1:45, but if not, if I, for whatever reason, overstate my case, please let me know. So this is the syllabus. And the homework, I think you've had 2 or 3 assignments that you've gotten, and I don't think of any more that we're going to have between now and the midterm, but this will continue to, we'll have some more homeworks as we go through the rest of the semester. The quizzes, right now, the only quizzes I have are the EC&M quizzes. So as you get those, look at them. They give you the answers. I mean, I'm not asking you to do anything other than just give me a sheet of paper that says questions and answers. But in so doing, believe it or not, you're getting a little bit of exposure to the National Electric Code, and I honestly think you should know enough about it that you can, as they say, cut your way out of a paper bag. I think you should probably not be afraid of it, and you know, one of the best ways to not be afraid of it is to dial up EC&M every week, and just look at the quizzes and see what they have to say and see what there is in that. And that's all that is EC&M is just a constant review of the National Electric Code. It's all it is. And they make a living at it. um, I've been bitten by stuff in there and had to take it on the chin and go back, and somebody says, well, what about this and what about that? And then they say, well, let's, you're not you're dummy, but you had 4 years of college at the university, blah, 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 and then whatever. And then, crawl back to my office and look in the code book and see where it's at and say, yep, they're right. And then you go back out and say, well, okay, let's keep going. But, you know, you'll never get enough of it. You'll get tired of it. You'll get so, whatever. But I honestly think that EC&M is a good source, and so that's what we're going to use it for the quizzes. Now the labs, you're going to do the labs with Ethan, and thank him for that very much. Now this midterm test coming up, here's 30%, okay? How are we going to get 30%? Well, I just posted a couple of other things, and basically I'm going to go over there and look at those right now. So I posted a project. I actually posted a couple things on the website. So how do you get through something when you don't have I know the subject pretty well. I've been able to do most of this stuff in my life and all that sort of thing, but how does one, if I was going to do this for 5 years, I would really work on this really hard. I may work at it and actually teach this course again. I don't really know, but I found an Eaton text, which is a very, very, very good text. If I would have known about it, I would have put it up here instead of the Gustafson text, but I didn't know about it. And then as I stumbled along, I found all this other stuff as supplemental text. And then I've got the Eaton text, and I've got a one-line problem. So basically, the 30%, I want you to do so for the 30% for your midterm, I want you to do a one-page review. So for the 30% midterm grade, 10% of that, or a third of it, will be a review of this Eaton text. And 20% will be a one-line problem. Okay? So you click on the Eaton text, you do a review of it. If it's good, and if it's a page, half a page, I'll take it. If it's just nothing. Oh, by the way, ChatGPT will get you there and give me a one-page review of the Eaton blah 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 text. ChatGPT will do you a wonderful job. I know that. I could get you 10 problems off of the whatever, and you could just, we could fight this back and forth all the time. If we want to, we could. But I would hope that you would read through the Eaton text, because we're going to go through a little bit of it today. We're going to talk about grounding today. And if you want to talk about grounding, you can. If you want to talk about something else, you can. But I want you to look at the Eaton text and find something or two or three things that you'd like, that you might want to know a little bit more about, and spend enough time writing about it in that, because it is kind of a very, very, if you wanted to know what I should have used for the first half of this course, this was it. Didn't find it until this last week. But this text right here, this Eaton text, is very good. It explains how to do one-lines. It explains a lot about a lot of things. It even goes into seismic considerations. Did you know that certain parts of the country are more prone to earthquakes than other parts? And you ought to consider that? They even talk about that, huh? So anyway, I'm not trying to belabor it, but it was a very, very, very enlightening text for me to look at. It shows all about one-lines, all about how to calculate the same stuff we've been through before. But I just want you to know that I think you ought to review it. And like I said, I don't care if you have a 1-page, 5-page, 3/4 of a page, whatever, but it'll be something that I'll grade you based on. If it looks like it's something that you did yourself and you really meant it, I'll give you the 10 points, okay? Now the 20 points on the one-line problem is really a very good problem. Now the one difference between the one-lines that are shown to you in the previous things and the one line that we're hoping for you to do here is this one line has an expectation that you'll size some things, like you will size the wire size and you'll size the breaker. So it doesn't give you the breaker sizes. So you need to basically come up with the breaker size for, if it gives you a motor, you need to find the breaker or the fuses for the motor. And the wire size. And the neutral and the ground wire. I don't, and the conduit? Okay, and the conduit. Okay, so you get the fun of doing this all the way through. Okay, was there a capacitor involved or not? You didn't say the capacitor. If you want to throw a capacitor in, you can, but you don't have to. The capacitor is optional. Okay, so that gives you a full about 20% of this course, which if you take it, and all the explanations are right there, so you don't have to go outside and look at all the stuff externally. But again, ChatGPT will get you everything you need to know, or Gronk. But basically, I'm asking you to look at the tables and try to figure it out from the tables. Any questions about that? And that will be due. This is week 6. Week 7 is next week. It'll be due on Wednesday of next week. Both of these will be due, and I'll post this. It'll be Wednesday next week. That'd be 9 days from now. So today is the 12th, 10th, something like that, right in there.
The 8th, Wednesday of next week.
Is that Wednesday of next week? Yeah. 10/8. Okay. And if you get it to me by, Friday, it's okay. But I need it before the break. Okay. Any questions? Any comments? That's a fair. It's a take-home test. Is what it is. It's a fair giving you something that you can now work at and look at. And if you have any questions between now and then, we can iron them out. That type of thing. Now, what I wanted to talk to you today about is this Eaton text and some subjects in here that you may or may not have ever thought about. But the one that really wanted to talk about was grounding. And honestly, we don't, and here's, again, these are some very good example problems that you can, it talks an awful lot about all kinds of distribution systems. This is a really complete book on one lines and. So you can look at this and you say, now what's he going to talk about after the break? Well, we're going to go into motors after the break. So we're going to drop the distribution stuff and we're going to talk about motors after the break. But designing a distribution system, this is as good of a book as you're going to find, and it's free. Okay? Now, I'm not necessarily an Eaton fan. I'm not trying to say that they're better or worse than anybody else. Uh, but it's certainly something that, it's an American company. It's not an American company anymore. They were bought out by, um, the parent company is in Ireland, okay? But their headquarters in the United States is in Cleveland, and they're very practical. And you probably want to know uh, who are the American brands and who are the various brands you can buy of motor control and all that kind of stuff. Well, um, there were always three big ones, and I don't know anymore if how they all stack up. But Allen Bradley, and then Square D, and then Cutler Hammer. Okay. Now these were the three that made motor starters, and they made all kinds of switchgear for motors and stuff like that. Now they were the three, and then if you got into large motors, then you had Westinghouse and GE. Okay, so these were for the big guns, and these were for the push buttons, pilot lights, all the stuff that was made. Relays, if you want to buy a relay, these are the three that made them. Okay, so what happened? Who's still around? Well, Allen Bradley was bought out by Rockwell, so they're basically still here. Daggone it. So, had Allen Bradley. Can't do this without messing something up. It became Rockwell. What on earth? Square D was bought by the French company Telemecanique. No, they were bought by Schneider. Sorry about that. That's the French. They're French. And Cutler Hammer, what am I doing? Was purchased by Eaton. Okay, so these are Square D is still around. They're now part of. Can't believe this. And Cutler Hammer became part of Eaton. which the parent company is Irish. Okay, so basically the Westinghouse went away. And then GE, same thing. They kind of vanished. Anybody use Westinghouse or GE on anything anymore? Totally no. Anybody hear of them anymore being used? Well, they were the two biggies and they've gone away. Okay, so now why did Alan Bradley kind of dominate? It's an interesting story. During World War II, these two companies went out and started doing contract work for the government. So they turned their factories into war plants for making, they went for the bucks. As Robinson said, these guys went for the bucks, these guys went for the ducks. These guys stayed as a motor manufacturer company. So they built motor starters, even though these two guys, and they're all three from Milwaukee. So these three companies all were founded in Milwaukee. And honestly, year after year after year, they roll out a new catalog, and the price per something was identical. And the joke was that their salesmen or that their marketing people met at some bar every year, and they came up with the price of what everything was going to be, and they all came together and said that's what it's going to be. So they're all three Milwaukee based. Anyway, so that's what that is. So again, but these guys right here were very brilliant in their marketing because they stayed with their product. So at the end of World War II, everybody that needed a starter, a motor starter or anything, had to come to these guys because these guys, they'd lost it. They'd lost their market. So now these guys had to build their market back, and they never did. This was always the dominant one. So anybody that had a starter would buy it from Allen Bradley, okay? So again, trivial, but yet 80 years ago, what was done 80 years ago is still around, and that's what we're still having is, and they also invested heavily in PLCs, Allen Bradley did. And that's why most of the stuff is Allen Bradley, because Allen Bradley did not, how do you want to say this? They weren't always the most brilliant people, but they were the most brilliant buyers of other people's technology. They bought a company up in, it was a startup company, a little company in Ann Arbor that had a PLC that answered the PLC thing. And they bought it and moved it to Cleveland, and that's became the Allen Bradley PLC division. Okay. So again, they're brilliant marketers. They've always been very, very forward-thinking marketers, and that's why they've stayed around. These two companies, Square D, bought out by Schneider, and Cutler Hammer bought by Eaton, and then Eaton was bought. If you look up Eaton, Eaton is an Irish company. I couldn't believe
Busman,
that.
isn't it?
Huh?
Busman.
Who?
Busman.
They bought Bussmann, yeah, Cutler Hammer and Eaton is Bussmann became part of this as well. So Bussmann became part of this company as well. So anyway, that's the long story of, you talk about this company, that topic. Now who's moved in? Siemens. Who else? Who else is big in this kind of stuff? Siemens and obviously Schneider, because does Schneider sell a lot of stuff anymore? Or is it marketed through
They sell a lot of defense and PLCs.
who?
Schneider, specifically for PLCs, sells a lot of defense.
Right. They sell they bought Modicon. So you've got basically Allen Bradley, Siemens, and who is the other one? Thank God it. What on earth is going on with this thing? Is the other Siemens? Okay, Allen Bradley, Siemens, and there's another one. Well, anyway,
I mean, if you're talking just PLCs, you got like Yaskawa, you got ABB, There's a bunch of PLC companies.
There are, but I'm talking about motor. If you wanted to go with the full line, the motor starters, the buttons and all that stuff.
Weidmuller?
Weidmuller?
Yeah, they do a bunch of
Yeah, yeah. Oh. Anyway, who is it? Telemechanique has Modicon, or excuse me, Schneider. So anyway, that's why the World War II thing was why Alan Bradley continued on and is still in the business, and whereas the other people have lost it. That's why they are still the players. And they're battling it out with Siemens. Okay, so typical, and this is this book. I want you to go through it and at least learn something from it. And then I'm going to go down and talk about grounding. Okay. And again, I'm no expert on grounding, but I do know that a bad ground or a lost neutral in a control circuit, they're hard to find and they're everywhere. If you can't, if things don't make sense in a circuit, it's because you have lost your neutral. If nothing makes sense, and I've had that many times where you start looking for a lost neutral, and that can clear up bunches of stuff. Okay, so somewhere in here, it should talk about grounding, and I thought I could find it very easily, but I can't. It just kind of eludes me now that I'm looking for it. But basically, what you want to do with a ground is to have one point that you have as your ground, okay? And then you want everything to emanate from that. And do not want to ground 24-volt control circuits. You do want to ground 110-volt control circuits. And the reason for that is because in most cases, if you're troubleshooting 110, if you can go to a water pipe or some other device, usually you can get a good ground. So I'm not trying to tell you exactly how to plan everything, but that's the typical one-off of how to make a circuit work. The problem that I have today is if you're going to go to a totally where did grounding go? They talk about harmonics here, which is something that, I never had to, okay, here's just something about grounding. This is, okay. Grounding represents the foundation of reliable power distribution. Grounding and wiring problems can cause up to 80% of all power quality problems. Grounding is a massive, you have to be careful of your grounding, and you also make sure that everything is grounded, okay? All other forms of power quality solutions are dependent upon good grounding procedures. And now, all that being said, I talk about surge suppressors, okay? And then they talk about the Emerald book and other grounding sources here. So if you have a surge suppressors are with the Emerald book. Okay, now the Emerald book, two states protection concept for large surge current diversion is the best. First, okay. Our panel. So surge suppressors are useful. Never use these, okay? Never ever used a surge suppressor. but you should read through this and at least know what it is. But I have not used these. Okay. So basically, thought there was more to this than there was, and there's power quality. Okay. So you have these things called ground loops, or ground current loops, and basically that is a fallacy. I'll show you how that works because that is important that you know that. So if you have a ground that's over here, in other words, you declare a ground over here, you declare a ground over here, and then you tie these two together, the potential at this point might be different than the potential at this point to earth ground. Okay, so the potential here might actually have a small variation in voltage. In other words, it could be like that. So I want to ask the question, if you have a battery with 1 volt on it, and you have this kind of a circuit, is there current that can go through it? And you betcha, lots of current. So you do not want to have a ground over here and a ground over here and a wire in between. That causes this kind of a circuit. I here can get really big. Okay? That's called a ground current or current loop. This is called a current loop. And that current can get really nasty. And it can heat up things and cause all kinds of problems. So basically, you do not want to have a ground over here and a ground over here and tie them together. If you have a ground over here, use it for circuits over here, and if you have a ground over here, use it for circuits over here, but never tie the two together with a wire. Because the possibility of a potential difference between the two, in other words, you come up out of the ground with a wire, and you say, what does that mean? Well, you basically pay the electricians to drive ground rods in the ground, and what they do is they drive them in the ground, and this is the 7-foot one, and then they attach it to another 7-foot one, and they may attach it to another 7-foot one. So you may go 21 feet down in the ground. You may not go that far down the ground, but you may, okay? And then you attach up here your wire, and you call this ground, okay? Now, I built an electric fence for my garden, and I only did one of these, one 7-footer in the ground. And then I tied that to my electric fence, and that worked. It worked very, 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 very well. If you want to get deeper, you can go more, hopefully getting a better ground. But they do that. But even with this, you can get a variance from point A to point B. In other words, I'm over here with my factory, and I'm over here in my factory, and if I tie these two together, I can get a current between those two that can heat things up. Believe it or not. So you don't do that. So everything that you tie to your ground, you tie to a single ground, and then that ties to this, and you do not tie this ground to anything this ground that's associated with this is not tied physically to any other ground that does the same thing, period. Okay? Does that make sense? A good ground is 2 ohms or less. Some people say 3 ohms or less. Some people say 1 ohm or less. The better, the closer to actual earth ground you get, the better. And if you can, you try to make sure that it is as close to 0 ohms to ground as possible, because that gets you a better, your electronic equipment works better if it's closer to ground, and especially your communications equipment works better the closer it is to ground. Okay? Now, how this works with 24-volt circuits, I don't know, because I've always been told, and you're going to have to figure this out for yourself, because I have no clue. But if you do this with 24 volts, and you run it through a control circuit, do stuff with it, and you go to an output or whatever, and you do stuff with it, you do not ground it. No ground, okay? No grounding of 24-volt circuits. Now, if you use 24 volts for controls as opposed to 110, what is the problem? Wire size. You may end up with something bigger than a 14 gauge or 12 gauge wire for control, which is typically what you use. You typically, for control in a plant, you use number 14 AWG, or for power, you'd use 12 gauge AWG. This gives you 20 amps. This gives you 15 amps. But very rarely would you use anything bigger than a 12 gauge. But with 24 volts, you might end up having to make this bigger wire. And that's why I think there's a push still to use 110 volts for controls. Out on a factory floor, it's used 110 volts. Why? Because of this. But I can't prove that. Now, the other way of doing this is to move your controls, move your I/O, in other words, move everything out to the device, and then have a network cable, have an Ethernet network cable to go out to the device. Here's the scenario. I've got some controls that I need to do on this little area right here. So I go out there with an Ethernet, and then have, daggone it, I can't do anything today. And then Ethernet and 110 for my power. So I take Ethernet in, and then I also take in 110 volts for my power to my power supply. So I have a 24-volt power supply. And one 24-volt power supply there, and my Ethernet cable in, and I don't have to worry about long runs. Has anybody seen that? I think that is the preferred way of communicating to machinery today. Okay? Anybody seen that? Anybody done that? It's the way I would look to try to. So this way, you do not have to. So you have these drops all over the place. And you do not have to worry about long runs of cord, so you can run 14 gauge wire in this little piece of machinery right here. You run 14 gauge wire, all to a 24 volt power supply, all to 24 volts, so you can work on this without having to worry about suiting up. So I think that would be the preferred way. Now, if you want to have the close, like they talked about, so we're talking about the practicality of working in a factory, okay? Do you want to have that class 1, 110 volts, 115 volts, that class 1, where you got to have the no cotton? Did everybody get that from that video the other day? No cotton? Okay. No cotton. Is that what your dad, what's he doing? How do they do what they do? Do you know?
I mean, he doesn't like work on equipment.
He doesn't go out and work on stuff?
No, we just,
Okay.
the field work that we did was just like inspecting
Okay.
stuff.
If you have to work on equipment to get it up and running, how do you do that? Do you do it at 110 volts or you do it at 24 volts? If you do it at 110 volts, you have to have, if you open a panel, the 110 volts in it, You're supposed to have that division, that class 1 clothing. You got that the other day. Don't wear fuel. Okay? Well, that meant that you basically have to wear the clothing that will not burn. That even class 1 is you have to, and you also have the meter. The meter that you would have has to be a rated meter for non-explosion. You can't take one of our meters. You can't take a $10 meter. Okay? Why is that? It could be a short. The meter could actually be a short and give you an arc flash, and then you wouldn't be dead, but you may have scorched scorched eyebrows. I don't know, but you at least have to have a rated meter and all the equipment so that you would be able to handle a Division 1 thing. Okay, so that's your lowest rating, but you are going to be rated at 110 volts. Okay, so to get away from being rated, have a panel that doesn't do that. How do you do that? And then how do you justify wire sizes? So basically, you're going to probably go Ethernet out to a remote drop, and then each of these areas you're going to have 24 volt power supply, and that's how I would design. Okay, it's been 40 years since I had to put my name to a drawing, but that's how I would do it today. Okay. You have to decide how you're going to deal with these things, okay? Some people are going to go one direction, some people are going to go another, but I think this is probably one of the better ways of going. And I'm just trying to wrap my brain about how would be the best way to do it. But the idea of grounding, do not create ground loops. Don't go between one. What on earth? I can't make it do it when I want it to do it, but if I just go up to it, it automatically. Do not have a ground over here and a ground over here and tie a wire between the two. Do not do that. Okay? Period. All right, that's simple grounding, but it is what it is. If you do that, that's a number one way of having heat related problems and burning things up. Okay, it will get hot. I don't know the details. I've never had one. I got this as an early when I walked out of college and started getting practical things. Somebody explained this to me, and I said, I see that. You know, if you have a volt difference between here and here, which you can, and you have 0 ohms resistance in that wire, guess what? It'll burn it up, or it'll get hot, cause problems, and it will cause problems all the way through. Everything will have problems because of that. Okay, so I don't really have a lot other than that. I thought I had more of that with the power, with the grounding, but it doesn't really. It does talk about a little bit here. Not a lot, but a little bit. And it also talks about power quality. And
Wasn't there a program that we could get like a 30-day trial for?
yes. Did you guys
I mean, I'm asking because I don't remember.
Yeah, the,
E
tabs.
ECAP, ECAP? If you want to try that, you're more than welcome. If you want to do it if you want to draw this by hand, be neat. But if you just want to use a straight edge, it's fine too. I'm not going to try to tell you which way to go, but it's you have to block it out and work on it. And I'm
Within the PDF on your website, one PDF, just
yes, yeah, and it gives you the rules for this. It gives you the rules for the sizing of the wire, the sizing of the conduit. It's all and the sizing of the breaker. It's all there. All the parts and pieces are there. You just have to find them. But it's all there. Very much, yeah, it's there. So anyway, I'm sorry I did not prepare as well as I should have today. It's been a theme in this course, but at least you got the basics of what you really have to be careful of with grounding, okay? And that said, anybody have any questions? You got your assignment? We will move on, and, right now, I don't know what Wednesday will be, but I will be here, and we'll talk about, we may move on to motors. I don't know for sure where we're gonna move on to, but basically, I think we're pretty well done with the power side of it. And we will do some more with the code, but, anyway, take care. See ya.